All right, today we're going to try something really cool. We're going to go inside the mind of an AI. We're going to explore how these large language models seem to understand our world, and I'll tell you the answer, it's probably not what you think. It has less to do with memorizing facts and everything to do with recognizing patterns. So let's get into it. Okay, so let's just start with a puzzle, right? How does an AI, which has never ever experienced the real world, how does it know that king is like queen or that doctor is related to nurse? I mean, think about it. It's not looking this stuff up in a dictionary or an encyclopedia. The answer, well, it lies in a kind of logic that is completely different from how a normal computer database works. And that huge difference? It really boils down to two core concepts. On one hand, you have what we'll call identity-based thinking. This is the world of databases, exact, precise, no room for error. But on the other hand, you have similarity-based thinking, and this is the world of LLMs. It's a bit more fuzzy. It's all about context and relationships. So let's actually break down what that means. All right, so first things first, let's really get clear on what we're talking about. What does it actually mean when we say a system thinks in terms of identity versus similarity? Okay, so identity. This one is all about an exact one-to-one match. The best way to think about it is your social security number. It doesn't point to people like you, it points to exactly, specifically you. In the digital world, this is absolutely crucial. It creates this stable, unambiguous link. There's no guesswork, no maybe. It's just a direct pointer to one unique thing, period. Now, similarity, well, it's a completely different beast. It's way fuzzier. It works on what we call probabilistic closeness. So instead of asking, what is this? It's asking something more like, what does this remind me of? What is it close to? You know that feeling when you see a face that looks familiar, but you just can't place the name? That's your brain's similarity engine kicking in. It's all about patterns and context, not exact matches. And this table really puts that contrast front and center. An identity-based system, it's going to retrieve one specific patient's file. It's totally deterministic. But a similarity-based system, well, it's going to find patients like this one. See the difference? It's probabilistic, it's flexible. So one gives you cold, hard certainty, while the other gives you the power of inference. Okay, so now that we've got the basics down, let's do what we came here to do. Let's peek inside the mind of a language model. How does an LLM actually use this whole similarity thing to think? So the first and most important thing to grasp is this. You have to stop thinking about words as just text. Inside an LLM, words get turned into coordinates, like points on a giant, high-dimensional map of meaning. We call it semantic space. And really, it's less like a dictionary and a lot more like a galaxy, just filled with constellations of concepts. And on this crazy map, distance literally means something. Proximity is meaning. Words that are used in similar ways in all the text it's read, they just naturally cluster together. So king ends up right next to queen. Cat is in the same neighborhood as dog. Doctor is close to nurse. The model isn't retrieving facts, you see. It's just navigating nearness. And this brings us to a really powerful idea, summed up perfectly in this quote. The model doesn't know what a cat is. It knows what tends to appear near cat. Just let that sink in. It has no definition, no concept of a furry, four-legged animal. All it has is a giant statistical map of all the words that tend to hang out around the word cat. For the AI, meaning is just an echo in a statistical neighborhood. So this way of thinking, it is unbelievably powerful. But it's also where the real peril comes in. This is truly the double-edged sword of thinking in similarities. It's what makes AI so intelligent, but also so dangerous. So first, let's talk about the incredible power this gives it. Thinking in similarities is what fuels intelligence. It's what lets you make analogies, connecting totally different concepts. It's what lets you see the bigger picture, to recognize patterns, and it's how you can guess what's going to come next. It's even the root of creativity, generating brand new ideas. This is the magic that lets us learn something in one place and apply it somewhere completely different. But, and this is a huge but, this is also why it can be so dangerous on its own. A system that only knows this looks like that is just asking for trouble. It can invent connections that aren't there. We call these hallucinations. It can draw the wrong conclusion from a bad analogy. It can link things that have no business being linked. And maybe worst of all, it can take all the biases from our human writing and just amplify them. Okay, so if thinking in similarities is so powerful but also so perilous, what's the solution? How do we find some stability in this probabilistic world? Well, the answer is you don't use it alone. You find ways to give it anchors. You ground it in the world of identity. And here's the really crucial point. Identity isn't actually missing from these systems. It's just working in the background. The documents they train on, they have unique identifiers. Those coordinates in the semantic space, they have unique IDs. And in really advanced systems using a technique called RAG, the AI can actually retrieve a specific passage from a specific document and trace it back. These are the anchors, the solid ground of identity in a swirling sea of probabilities. And what's so fascinating about all this is that it's not just some clever engineering solution for AI. Turns out, it's a pretty good mirror for how our own brains work. We are also hybrid systems. No, really, think about it. When you recall your social security number, that's your identity brain at work. It's an exact reference. But when you see someone and think, that person looks so familiar, that's your similarity engine firing up. Remembering your exact birthday, identity. A certain smell that suddenly reminds you of being a kid, that's similarity. We are constantly, seamlessly switching between these two modes of thinking all day long. And all of this brings us to the future, right? To the big picture. The future of intelligence, whether it's ours or the AI's, isn't about picking one or the other. It's not identity versus similarity. It's about where certainty meets inference. It's about combining them. Yeah, the goal is absolutely not one or the other. The future, the real prize, is building systems that are identity anchored, grounded in facts, but that are enhanced and supercharged by the power of similarity-based inference. There's a really beautiful and simple way to put this. Identity names reality. Similarity explores it. Isn't that great? Identity gives us the solid fixed points on our map. These are the known facts. But similarity, that's the engine we use to explore all the vast, unknown territory between those points. So in the end, you have these two fundamental acts of cognition. Identity is all about answering the question, what is? Its job is to stabilize our knowledge. But similarity, it's all about exploring. It asks, what does this resemble? Or what could be? Its job is to expand our knowledge. And for real intelligence, real understanding, you absolutely need both. And that leaves us with one last, kind of mind-bending thought to chew on. We've just talked about how true intelligence is this masterful blend of identity and similarity. So, what happens to our world when the machines we're building get better at that cognitive balancing act than we are? And that question, well, that's when things stop being just about technology and start getting really, really profound.